My friend and I did it in 40 minutes. So you can, if you know what you're doing, it can go by pretty quickly. But we also spent like a long time before trying to like mess. I mean, we were also trying to do it like we didn't like look up a guide. We try to do it like organically. Essentially, we try to do it like by ourselves. So we it took us like quite a bit of like several hours at least just to like get up to that point. But if you know what to do, you can do it in like 40 minutes. Yeah.
All
Um.
right.
Yeah. Okay, hello everyone. So let's get started with today's warm up of the day. Today we are going to be talking about a lot. We're going to be analyzing a lot of data. And so before we analyze data, we first want to talk about what makes a good scientific experiment. So we want to talk about what makes a good scientific experiment. How do we know if we can trust the experiment? How do we know if the experiment is trustworthy? How do we know if we can trust the results? So we have 5 choices for you. We have one. Is does a large sample size help with the trustworthiness of a scientific experiment? What about is it repeatable by everybody, by anybody? Does that make it trustworthy? If it has a clickbaity headline, does that make it trustworthy? If it showed up on your Facebook or Instagram feed, does that make it trustworthy? If it's peer reviewed by other professionals in the field, does this make it trustworthy? So what do we think makes a scientific experiment trustworthy? We currently have 14 people in our class right now. Let's try to get that 100%, that 100% participation. So let's try to get all 14 responses in here. We're currently at 8, so we're doing okay. We're getting there. But let's take a few minutes. Pick all these that apply. That's multiple choice, a true multiple choice question. So which of these do we feel like helps make a scientific experiment trustworthy? So does it have a, so we currently are at 16 people right now. Let's try to get 100% participation. So we need about 6 more people. So question, how do we know if a scientific experiment is trustworthy? You want to pick all that apply. Does having a large sample size make a scientific experiment trustworthy? Does it need to be repeatable by anybody? Does it need to have a clickbaity headline? Does it need to show up on your Facebook and Instagram feed or your Instagram feed? Does it need to be peer reviewed by other professionals in the field? So we are currently at 12 responses out of the 18 we need. We need to get those 6 other people. For those of you just joining us, make sure you answer the warm-up question right now. How do we know if a scientific experiment is trustworthy? Pick all of that apply. We need about 5 more to get 100% participation. We're currently sitting at 13. We want every single participant, every single person to respond. Every vote matters. So it will take another minute or two to quickly respond to the warm-up question. How do we know if a scientific experiment is trustworthy? Pick all that apply. We're currently at 19 people, which means we need 6 more responses. So let's take 1 more minute to answer the warm-up question, and then we will move on. We want to get 100% participation. We are currently sitting at only 14. We need about 5 more. So I think we can do 5 more. I don't know. We'll see. Let's take 30 seconds or so to get those last few votes in. All right, 3, 2, 1. All right. So let us talk about what indeed makes a scientific experiment trustworthy. So first off, Does a large sample size help make it trustworthy? So first off, a large sample size is indeed very important for a scientific experiment. So the reason why is because you can't draw conclusions off of one thing you saw, right? You need to have a large sample size, so that way you can figure out if it's just happened by chance or if it actually was, or if there's actually a bigger trend behind it. So a big part of science is looking for trends, not looking for one specific data point. We're looking for many, many, many data points. And the larger sample size we have, the more accurate our data is, right? If I measure data from 2 people, that's not going to be very accurate because it's only 2 people. You know, if I measure data across 1,000 people, right, we can trust that data a lot more because we, at that point, we've sort of accounted for just random things that happen in life because life is very random. So large sample size is indeed very important for a scientific experiment's trustworthiness. Is it repeatable by anybody? This is also very important. Science needs to be repeatable. If you do one experiment and nobody else in the world can repeat that experiment, how do we know if we can trust your results? Because if we can't recreate the same results on our own in our other lab, right? We can't trust your results. You could have just made it up. So it needs to be repeatable by anybody who is trying to repeat your experiment. As a clickbaity headline. Ooh, this is a good one. So a clickbaity headline does not mean a scientific experiment is trustworthy. In fact, a lot of the times a clickbaity headline actually makes it untrustworthy because the point of science isn't necessarily to just capture your attention. Right? The point of science is we're trying to test something and we're trying to prove something, we're trying to collect data on something, and that in itself is not really related to the clickbaitiness of something. So when you see, if you see something that's clickbaity, I would take caution with it. It is not necessarily trustworthy. Part of science is being able to think about what is trustworthy, what data is trustworthy, what experiments are trustworthy, what do we believe is real science, and that is what that is not what clickbait is, unfortunately. It shows up on your Facebook and Instagram feed. Ooh, this is very popular nowadays. You'll see a lot of stuff on Facebook and Instagram and TikTok. I don't even know what other social medias are on there. Twitter, for example, is another one. A lot of the interwebs have a lot of news that come up and a lot of science that comes up, and the reality is, if it came up, it probably is not accurate. It's a good scientific experiment. Good science is not really found on Facebook. You find it off of trustworthy scientific sources. So a scientific journal is a really good place to find it. News are a little bit better than Facebook, but even then, right? If someone's goal is to try to get you to read it or to capture your attention, that is not science. So be very careful with stuff that shows up on Facebook and or Instagram. And last but not least, it is peer reviewed by other professionals in the field. This is also very important as well, right? You can conduct a scientific experiment that is, repeatable and has a large sample size, right? But if you do it and your professionals are peer reviewing it and they're like, I don't think this is accurate, then that probably means that there's something wrong with your methodology. That it means that you did something wrong. So that is very important, right? When you conduct an experiment, right? We want to be able to review it and see if it indeed makes sense. So today we're going to be analyzing our scientific experiment, and we're going to try to, determine if we're going to try to find out some trends, try to make some do some data analysis here. So in terms of what our scientific experiment had, so again, we measured a lot of times for people doing a bunch of running and walking experiments and stuff. I try to collect as much data as we can. I'm not going to use all of it because some of the data just didn't really make sense or wasn't really usable. But the key things about our data set that I try to make it good science was that our data set, I use the data from 3 classes. So I try to get as large sample size as possible. It is repeatable by anybody because you can easily go out and do the experiment if you don't trust the results. And right now we are going to peer review it, essentially. We're going to take a look at the data and then we're going to try to make some analysis on it, try to determine some trends. And so we are going to be peer reviewing the data as scientists. So that's what we're going to be doing today. So, okay, so what are we doing today? So today we're just doing one thing. We are going to analyze our data. So I'm going to put a link in the chat right now. It's also on Canvas. The assignment name is just called Acceleration Data Analysis. I don't have a cool name for it, unfortunately. Usually I have some very fun names, but this one I don't really. So open that up, and that's what we will work on today. In terms of a due date for this, I don't really have. I'm tentatively setting this for the Thursday after we come back. So we'll have a couple of class days on it to work on it at least. So I'm hoping that should be enough time We will see if this due date makes sense, after the break. Right now, I'm just trying to project a plan ahead here. So that's what we're going to do today. We're doing the acceleration data analysis. So make sure you open that up. We will have some time to work on it. So, all right, what does this data analysis involve? Okay, so right here, what happens is you have, what I did is I pulled data from 4 different experiments. And for each experiment, I graphed it. I put it on a graph so you can visualize it. And our goal here is trying to analyze the data by answering the prompts following each graph. So each graph is going to have basically a question for each graph that you're going to try to answer. Each prompt is going to have a little sentence starters that you can choose from to just help you write, but they're not mandatory. You don't have to use the sentence starters. And there's also a word bank that you can use to help write your answers. In the word bank, the bolded words need to be included because those are very conceptual words that we want to practice using, get a better understanding of them. So you need to use bolded words. There are other words in the word bank that are highly encouraged to use because they can definitely help you write your analysis for each question, but you don't have to use all of them. But they're there to help you, right? If your response is using most of these words, then that probably means that you're on the right track. So there are 4 sort of experiments I made that I put it on here. The first experiment was we took our running stride length and we compared it with mile times. So I plotted this on a graph here. I've compared people's stride lengths in terms of feet with their mile times. So higher mile times are up here, lower mile times are down here, and we plotted this on a data. And I put a little trend line there as well. And so your goal here is to try to explain. So there, in this question here, the graph here has a general downwards trend, right? Generally means that as your stride length gets faster, your mile time decreases, it gets faster. So your goal here is to try to explain why this happens. Why would a longer stride length mean you have a faster mile time? And I want you to use good reasoning to explain the evidence and the trend. So what do I mean by reasoning? By reasoning, I don't just mean restating the evidence or just saying what's there or just saying I believe this because longer strides mean faster miles, right? That's not exactly what I mean by good reasoning. A good example, I'm gonna give you a couple of examples of reasonings. So let's say hypothetically you're comparing planes and cars. So let's say, for example, a basic reasoning example would be something like planes are faster than cars because planes have a max speed of 600, whereas cars have a max speed of 100. So you're pretty much just stating facts here. You're not really analyzing it. You're just saying that because there's a fact, therefore you're making a conclusion. You're not really explaining your reasoning here. I don't really see why this makes sense, right? A better reasoning example would be the following up. So planes are faster than cars because an hour instead of 100. But I also told you why they can travel faster. So I gave you both evidence and a good example of reasoning. So when you talk about how stride length affects mile time, I don't want you to just cite in, okay, this data point or this data says this. I want you to go beyond. I want you to really explain why this makes sense. Why does this occur? So give your sentence starters here. You have 4 words in bold. You need to use for these 4 words. And then the rest of these you can use, but you don't have to. The second experiment here is we measured a person's, every student's maximum speed, basically how fast they physically were able to go. And they used the speedometer for this. And we compared their stride length with their maximum speed. And we plotted this on a graph here. And so this question is a little bit different. In this question, we have 2 people, Ron and Hermione, both from Harry Potter. So Ron claims the data from experiment 2 suggests that, so we have 2 claims here essentially. Ron is claim 1. Ron claims that the data from experiment 2 suggests that people with longer strides run slower than those with shorter strides. His evidence is that one student with a shorter stride length of 2 feet, which right here has a speed of 19 miles an hour, whereas another student with a stride length of 5 feet had a slower maximum speed of 12 miles an hour. So Ron says that people with longer strides are actually slower than people with shorter strides. Now Hermione says the opposite. She thinks that the people with longer strides actually run faster than people with shorter strides using the same data from the experiment. However, Hermione isn't really sure how to prove her claim, and she isn't really sure how to refute Ron's claim. So what would you say? The question is, what would you say to support Hermione's claim and to refute Ron's claim? So once again, a couple sentence starters, some word banks for you to choose from. Yeah. The third experiment is probably the one that I think is probably the hardest one to understand. So this one is, you're basically, if you've ever done liners before, basically what happens is everyone started in the middle, they ran 12 feet to the right, they ran 24 feet back to the left, and then they end up in the middle again. So they basically went right, left, right. And so this graph here showed how long it took for them to run to the right, run all the way back left, run to the middle, how long it took for them, and it plotted them as a function of their 24, as a function of their heights. And so your goal here is to try to explain how does this experiment measure acceleration, and then how does the data support or refute your hypothesis about height and acceleration. Last but not least, we have one final experiment here, one final prompt. This experiment measured how long it took for us to run 24 feet with 3 different stride lengths. So for the first, for the blue trial, we took strides of 1 foot long. So each stride was 1 foot long, very, very short strides. The second experiment, we took strides lengths of 2 feet. So each stride was 2 feet long. And then the last experiment, we took strides lengths of 3 feet. So each stride was 3 feet long. So our goal here is to try to figure out what do you notice about the data and to see if you can determine any trends or relationships between their stride lengths and their times. Sentence starters here again, and some work and a word bank for you. So that is pretty much it. That's what we're going to be doing today. I'm hoping that we will be able to make some good progress on these, maybe do 1 or 2 of these, and then we will have the rest of the period to do so. So I will now send you into your, if you have any questions, please let me know and I'll be happy to answer them. Other than that, that's what we'll be doing for the rest of the class.